Okay, so you can see that. Cool. So I chose this one because it looks ugly. And I like things that look ugly, so I can show you that they really aren't. This one is just look at the darn picture and find the sum of torques, and will it go up or down? So the first thing you need to notice, and this didn't make it real clear, but this is the pivot point. So this is like the hinge or whatever something can be hung from or supported by. So in this case, we're talking about a hinge. So we have several forces going on here, and we need to remember what the definition of torque is. So torque is our force times our distance at an angle, sine theta. And remember, this is simply looking for the perpendicular component of whatever the force is, because if it's not acting perpendicular to, we don't have a torque. This is why if it's at 90 degrees, I'm sorry, at a parallel to rather than at 90 degrees, 90 would be perpendicular, then you have no torque. And some of those conceptual questions that you get, I think I did one as an example. It's if you have a merry-go-round and everybody jumps off tangential to, so I'll draw my circle. If everybody jumps off tangential to, so this way, do I have a torque that's perpendicular to? I really want everything to be perpendicular. Tangentially. Not tangentially, that's why I'm messing myself up. So if we jump off this way instead of tangentially, then we have no torque, because this is acting at 180 degrees. It doesn't create a torque. If I jump off this way, I am creating a lever arm and some torque. That is our rocket problem that we did in class. Okay, so this sine theta just says we just want this component, the piece of this that ends up being perpendicular to, and that's all that's doing. And so you look at this guy and you're like, oh my gosh. And so I have 0.2 meters, I have this 50 newtons, and I have this at 60 newtons, and I have this at 70 newtons, but now we're 0.8 meters away. And then I have this guy at an angle, and now I have a meltdown because I need to do some sort of trig, and I freak out when I start thinking about my sum of forces. But remember, torque is already set up that way. So if you have something at an angle, we already know we want the sine component of that. So it's no big deal. Now let's look at what's happening with this guy. At 60 newtons, that's our force. This torque equals 60 times, well, it's at my pivot point, 0. So at my pivot point, if I have a force acting on it, it's nothing. It goes away. What about this guy? Well, I have 50 newtons acting up. So torque equals 50 newtons times the distance away times 0.2 meters times sine of 90. Which this is just 1. This is why we ignore it all the time. That's just 1. So we end up with 50 times 0.2. Okay, let's come back and we'll talk about our sines. So now let's move over to this guy. That torque, I'll call that torque 2, just to be honest. So torque 1 equals 0. And can we still see? So okay. So torque 3 is this guy. So we're 70 newtons, and how far from the pivot point? Well, we're 0.2 plus 0.6, so we're 0.8 meters total. And again, sine of 90, so times 1. Now we get to this guy. Ooh, it gets scary. Torque 4. So 80 newtons. Now it's just 0.6, I'm sorry, 0.2, 0.8, 1 at 1 meter. Now that angle matters, sine of 30. So I just want to make this clear that this is all we have to do. Now we need to figure out, because the second question, we'll add these up, but the second part of the question is, will it open up or down? So hopefully you look at this and think, okay, so I'm going to have to do something in terms of down and something in terms of up. We can't say that that they equal each other, because if it's opening, it's not a balanced system. So we can't say counterclockwise equals clockwise. Now let's talk about our sign. Actually, I see it both ways. I see people see counterclockwise as positive, and some people say clockwise is positive, and you do this, and you're like, oh, counterclockwise, my thumb's up, it's positive. What I want you to do is not freak out over that. If you cannot remember which is which, don't worry about it. So think about this. Define what is positive and what is negative, because the question doesn't say, will it be positive or negative? The question doesn't say, will it be positive or negative? It says up or down. So this is the same thing that we've done before. You just need to define what is up and what is down. Your signs then will fill that in for you. Because remember, I don't get into is that negative or positive, but you do need to know what direction something is going, right? So let's call up positive, just for fun. If up is positive, then this one and this one are both positive. So my 80 and my 50, this is positive, and my down is my 70, that is negative. So now we want to know, are we up or are we down? Well, if we start cranking these guys out, this 50 times 0.2 is going to be plus 10 Newton meters. And this 70 times 0.8 is, yeah, it is 56, is minus 56 Newton meters. And then this is just our 80. It's kind of nice. Why do I feel like I'm forgetting something? Oh, sine 30. Huh, it's not 80. I was forgetting something. So this one would be 40 Newton meters, and this is up in my up direction, so plus 40 Newton meters. So I add all these things up, and I end up with a plus 40 Newton. Oops, not 40. More coffee, plus 6 Newton meters. So how did I define up? I'm positive. I defined it as up. So this is going to open up. And that's it. So just remember, with these torques, it is our lever arm, and this is the however long the wrench is. You go for the really big Mongo wrench when you have something that you want to get loose that's stubborn, because that force over the distance is amplified, and that's what we define as a torque. So it's just whatever distance away these things are, times the force applied, times the angle that it's applied by, because we're looking for the perpendicular component. And don't worry about counterclockwise or clockwise. You know, if this was actually rotating and I wanted to know, is it counterclockwise or clockwise, then define your motion. If you define your motion as positive or negative and you stick with that, then when you come down here, you'll come and you'll say, okay, so I define positive as up, therefore it's up. Just like that.